So the initial plan was to set up an IPv6 only testbed, and that's what we worked on for the first couple of months when we got on the project. We set this up in our Department of Computer Science. So one thing we had to ensure was that this IPv6 traffic wouldn't be affecting any other devices on the same network. And one reason why we had to ensure that was because we planned to look at a DHCP-V6 server, a DNS server running on our testbed. And if we allowed that traffic to go to the other devices, it would probably cause a lot of chaos in the network.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time, I'm talking to Vanessa Fernandez and Kavya Bhat from the National Institute of Technology, Karnataka, which is in Mangalore in India. NITK has almost 50,000 endpoints in a campus-wide network, which ultimately will have to encompass a 40-kilometre campus expansion. They've got over 350 switches, 1,200 Wi-Fi access points and a campus data centre with servers. They've also been running a multi-year student-led project to deploy campus-wide IPv6. 2 faculty members are overseeing the project, but they also have alumni from past years and an advisory group which include Nalini Elkins and Dhruv Dhody from IETF and ISOC, respectively. Vanessa and Kavya have now graduated and entered the workplace. They'll become alumni in due course for a new crop of NITK students, who will in turn continue the deployment onward. This episode of Ping is a reminder that large deployments often happen largely with volunteer and sometimes previously untrained hands. Vanessa and Kavya presented at 2 IETF meetings on deployment experience and measurements of their network with assistance from the APNIC Foundation under an ISIF project. Hello and welcome to Ping. Vanessa, Kavya, could you introduce yourselves, please?
Sure. I'm Vanessa Fernandez. I'm a recent undergrad from the National Institute of Technology, Karnataka, and I was part of the IPv6 migration team there.
And Kavya?
Hi, I'm Kavya Bhat. I'm a recent undergrad from the National Institute of Technology, Karnataka. And along with Vanessa, I was part of the IPv6 deployment team that worked on migrating the campus network to IPv6.
So you were both students in 2023 in a university in Mangalore, weren't you, at the NITK? Vanessa, could you describe the university a bit? How large is it?
We're a fairly large university campus. In terms of the network, we have more than 45,000 terminals connected to the internet. And we also can keep in mind that we have an upcoming campus expansion, probably within 40 kilometers of the existing campus. In terms of our infrastructure, we have more than 350 switches, 1,200 indoor-outdoor Wi-Fi access points, and we also have a dedicated data center within our campus. It hosts all of our critical infra like the firewalls, the core switches, any of our web servers, application servers, servers for DHCP-V6, DNS, and so on. And in terms of our population, we have more than 7,000 students within our campus, residing in our campus, and more than 600 staff, teaching and non-teaching staff. Yeah, that's about our campus.
So Kavya, is this like a single building campus or is it a multi-building location?
It's multiple buildings. So we have across like about 200 to 300 acres, we have like different buildings such as the administrative building, different departmental buildings for computer science, IT, electronics and such. And then we also have the hostel buildings. So it's multiple buildings spread across a pretty large area.
And this work that you were doing, I came to learn about this as part of IETF118. There's been this program where we've been looking for people to bring practical deployment experience in IPv6 into the standards process so that we can understand things better. This was the project that you were working on, right? You were actually doing a V6 deployment at your university.
Yeah, this was the project that we were working on. So we presented pretty much what we had done so far at IETF118 in terms of deployment and also in terms of this testbed that we had set up and the applications that we were able to migrate at that point.
And Kavya, you were working with a professor on campus, Professor Tahiliani. I mangled that. How do I pronounce his name?
His name is Professor Mohit Tahiliani, and he is sort of our guide in terms of a lot of projects that we do at NITK. And it was through him that I got to know about a lot of opportunities, such as this one. And when he asked about whether I'd be interested in joining the project team, I definitely said yes.
How big was the team?
It started off as a small team. So we actually had Professor Mohit and another Professor Soumya Hegde and two alumni students, Sushant Rao and Akshay Revankar, working on the IPv6 deployment thing. And after this, when our alumni graduated, we needed students specifically working hands-on in the campus. And that's where Vanessa and I joined in. We had worked on previous projects with Professor Mohit, and through that, we kind of knew of this opportunity.
And Vanessa, this was also working with Nalini Elkins, I believe?
Yes. So Nalini and Mike were part of our advisory team along with Dhruv from ISOC.
Yeah.
So this whole team of Professor Mohit, our alumni, Nalini, Mike, Dhruv, they were really instrumental in mentoring us throughout. Followed the format once every 2 weeks or once every week to kind of catch up and see what work had been done, what could be done, what were the problems we were facing, how we could tackle these problems. And they just gave us mentorship throughout and, helped us work on the project, present at the IETF, things like that we really didn't have much experience in.
So you said that this is about 45,000 terminal devices to be connected and quite a large number of switches, 350 switches and 1,200 Wi-Fi points. So I'm guessing you already had quite a large body of work here, finding the devices, getting consoles, getting images worked out. There was a lot of pre-planning involved in this, wasn't there?
This was sort of formed as a project proposal to get a grant to work on it. There was a very detailed plan of action that was laid out, and that involved figuring out our addressing plan, figuring out how we would migrate individual VLANs, and then ensure that connectivity was up while also deploying or enabling IPv6 routing on particular VLANs.
So what size IPv6 block were you working under? What was your amount of V6 address that you had to work with?
We directly got a /36 block that was leased from IRIN, and we asked BSNL to advertise that particular IPv6 block that we leased.
So BSNL is the university's upstream?
Yes, the BSNL router acts as our upstream.
Yeah. And your plan for an address map over this, you were doing subnets for each switch. Did you have a structure diagram in mind for how you were going to allocate the address plan across this? What was your population that you were figuring on putting per switch? Maybe that's not how you did it, actually. I'd be quite interested in knowing how you decided to subnet this, because it's not actually immediately clear that you need subnet structure here. So did you discuss running a layer 2 flat network across all of these switches, or was it a given that you were going to have a hierarchy?
So I think we decided to sort of stay a bit with our IPv4 addressing scheme, where we had different VLANs for different administrative buildings. So we kind of went with that and gave particular subnets to particular VLANs.
Did you do a population count? So you would give more addresses to a network if you knew that it had a higher density of students? Or were you able to give everyone pretty much exactly the same sized subnet structure?
I don't think we did any such pre-calculation for assigning addresses. Maybe we should have in hindsight.
No, I don't. It's not a given at all. The thing is that in V6, it's so different to V4, right? In IPv4, you would be counting every individual host to make sure you didn't have too many. But in V6, well, it is relative abundance, right?
Yeah, that's true. And that's probably why we kind of stuck to the V4 addressing scheme, and pretty much whatever we did with V4, we thought would be a fine template for us to use for V6 as well. So
You obviously didn't start, I know, let's tomorrow turn on V6 on the entire campus. Boom, done. Let's go and have a cup of coffee. What did you actually start with? You started with a test bed of some kind?
Yeah, so the initial plan was to set up an IPv6 only testbed, and that's what we worked on for the first couple of months when we got on the project. We set this up in our Department of Computer Science. One thing we had to ensure was that this IPv6 traffic wouldn't be affecting any other devices on the same network. And one reason why we had to ensure that was because we planned to look at a DHCP v6 server, a DNS server running on our testbed. And if we allowed that traffic to go to the other devices, it would probably cause a lot of chaos in the network.
Well, you would have had random devices picking up V6 addresses everywhere. That wouldn't have been very good. So you ran a small isolated network and you gained experience with running the fundamental building blocks of a network, a DHCP v6 server and a DNS server. And you didn't do stateless autoconfig. You decided not to do Slack.
So we decided not to do Slack in our production environment. For that reason, we based most of our experiments on DHCP-v6, but we did try out Slack on our testbed as well. Like we did try out configurations, router advertisements, and things like that, just to see how it would work in the grand scheme of things. But for a production environment, the idea was pretty clear to only use DHCP-v6, which is why we based most of our experiments on that.
So you were looking at a fully managed network where address assignment was explicit to device. You weren't just going to allow random hookups here. People have to provision. Do you already have a campus network management system that you were looking at targeting?
On the staff side of things, they do have a network management service, OpenNMS, that they use to monitor devices on the network. One thing we haven't explored yet is whether OpenNMS specifically supports IPv6. We didn't look at the network management systems yet. But with that in mind, we chose to not go with Slack and prefer DHCP address leasing.
So what was that experience like in general? Did everything work smoothly? Was it just instant okay, or did you find any little corner cases you had to look at?
This was the first experience for both of us pretty much working hands-on with IPv6, and setting the testbed up and getting it to work end to end was not really as straightforward as we thought it would be. So there were quite a few issues. Some that I can think of on the top of my head were setting up the VLANs. Sometimes the DNS server would not work as expected and things like that. So there were many issues that we faced along the way that we would spend quite some time debugging. So yeah.
Your presentation at IETF118, I think it noted that you had some unexpected outcomes with things like router signaling in DHCP v6. The systems just didn't behave quite the way you expected by default?
Yeah, I think the issues we highlighted there were with respect to the DHCP v6 relay. One of these things was that we'd see the relay forward message going out from the client, reaching the end server, but we never saw the relay reply reaching back to the client. We were initially very confused about what was going on because all the messages seemed to be going fine from the client, reaching the OpenSense router that we had set up, and reaching the DHCP v6 server. And then we kind of concluded after a bunch of packet traces and on the different hosts that it was probably an issue with the L2 managed switch that we were using, and that it was somehow dropping the relay reply messages when we had a DHCP filter turned on. So we had a lot of issues. This is where we spent hours, sometimes days, debugging it, discussing it with our professors, with our mentors. And it seems to be a hardware issue, but this is again something that we plan to test with another switch and conclude properly on our results.
There are some concerns that people have talked about in scaling aspects of the v6 protocol to suit large deployments like neighbor discovery and the risks of flooding. Did you do anything that was kind of in the defensive space, constructing limits and checks on the way people were using this service? How did you actually monitor how things were being deployed?
Again, with respect to neighbor discovery, we mostly worked on the testbed. We haven't explored too much in the production network. But there's this one feature called neighbor discovery snooping, where the switch will filter neighbor discovery packets based on IPv6 address to MAC address table that it has constructed. And on our testbed, one thing we noticed was that if the systems were connected and then we enabled this feature, we'd never see those entries being generated and put in the table. And we were always confused as to why, because while it should filter those messages, and that's what you would expect to see. And after, again, a couple of hours of debugging, we found out that if the system newly joined the network, say it was unplugged or turned off, and then it newly joined and started broadcasting neighbor discovery messages, we would see those entries being generated automatically. And we feel this could be a useful feature to have on our production network, but it would require some sort of static IPv6 address to MAC address binding, because again, if a new host automatically comes on the network, they could advertise any particular address they wanted. So there are definitely some security aspects that we still need to explore, and that's part of our next steps for the project.
So Vanessa, I think you were also looking at the DHCP-v6 server using a real database persistent store rather than just memory-backed state. Were you actually doing code work on that?
Not much code work. So the aim was to just look into the production environment best practices for DHCP-v6, like load balancing, whether we would need a redundant server or not, what type of redundancy we want to introduce and things like that. And then also migrating our backend from the basic mem file storage to a more persistent database like a SQL database in the backend. So I hadn't looked into scripting or something like that, but just the migration of the database from mem file to a persistent database.
So the capability was built into the tool. You just had to select the right options for it to go into a deployment in the field rather than just as an experiment.
Kind of, yeah. So we would have to set up a SQL database in the backend and then give the DHCP v6 server access to that database, and then it would work fine, yeah.
So what state of deployment have you actually reached at the end of this activity to date? Do you now have a fully enabled campus, or are you still in deployment phases VLAN by VLAN?
We're currently in deployment phases. So we've managed to migrate our data center VLAN to IPv6, which is great. And we've also set up a DHCP v6 server at the data center VLAN that serves our TRIPC VLAN, that's our central computing center VLAN. So that's done, but we now are looking into setting up a VLAN, which is a trusted VLAN, and we would add trusted users to this VLAN, enable IPv6 routing on it, and see if there are any potential issues that need to be addressed. If everything goes fine, we hope to migrate VLANs one by one, maybe start at the hostel buildings, the academic buildings, and so on, and just totally expand our migration.
What did you present at IETF? What did you find most interesting about this activity that you presented to IETF?
I think the first IETF we attended, IETF118, was at the point where we had almost completed setting up our testbed, and that was one of our first activities with respect to IPv6 hands-on work. And there were a lot of challenges we faced in terms of initial understanding of the particular protocols or how they were expected to work. Even when deploying, we would see issues where we weren't able to ping the external internet in some cases. We'd have DNS resolution issues. And these findings were something we were particularly excited to share because as students, we were looking forward to interacting with the whole IETF community and getting input on how things worked or whether our observations were as expected or sort of out of the blue.
And for the second presentation that you did at IETF119?
So for the second presentation, we had a couple more updates in terms of issues that we had faced on our testbed. Like as Kavya mentioned, at the first IETF, we had just finished setting up our testbed. So there we received a lot of feedback on things that we could try out. But at our second IETF, we had already tried out a bunch of things. For example, the DHCP-V6 filtering, which was a problem that we had faced, the neighbor discovery issues, even DNS scope. Sometimes the end client did not receive information from the DNS server, and also some router advertisement configuration issues that we had faced. So there were a couple issues like this that we wanted to bring up. And as Kavya mentioned, just see if this was something that only we were facing or if other enterprises were facing similar problems during deployment as well.
So you wouldn't have gone into this activity completely cold. You did V6 training as part of your entry into this. I think you've told me previously that you did some APNIC Academy work. Is that right?
Yes. So before we joined the project, our professor suggested to us that we do the APNIC Academy IPv6 tutorials. So that was my first introduction into IPv6. And along with that, we also did the labs, which we found really, really helpful for the testbed deployment, because there were some useful labs, especially the APNIC lab on Kia DHCP-V6 server. That was one that I can think of at the top of my head that we went back to again and again just to make sure we were doing things right.
So it's a virtual network setup. You're actually doing configuration on routing and switching infrastructure in a virtual network.
Yes, those are all VM setups, and it's playground pretty much for us to configure our own servers and end clients.
Happy eyeballs. Everybody wants to believe that the minute you deploy IPv6, that's it, boom, game over. People stop using v4. But it isn't really that simple, is it? So, Kavya, did you do any work measuring happy eyeballs and the relative amounts of usage?
We didn't specifically work on happy eyeballs itself, but we did observe some statistics from IRIS, which is our student portal. It's our learning management system. And the statistics obtained from that showed that in some cases, with certain OSs such as Windows, we were seeing that there were more IPv4 hits from users rather than IPv6. So when we discussed these results with Nalini Elkins, at that time, I think happy eyeballs had been discussed a bit. And we thought that maybe happy eyeballs could be a factor for that, but we didn't specifically go into measuring or testing if that was the definite reason.
Just want to add that we did bring up happy eyeballs at IETF118. I mean, we thought it was a potential issue, as Kavya mentioned, but we realized later on that at that point, most of our on-campus population, like the staff and students, were using Windows laptops or Windows devices. And that's probably why we saw more IPv4 hits versus IPv6 hits. Like there was no IPv6 routing enabled on campus at that point.
Right.
And all of our staff and students would be accessing IRIS through v4.
Whereas the VPN access and the remote access would have included more people on mobile devices. And because mobile handsets are dual stack, and because you already had from the alumni a dual stack deployment in the VPN, you would have seen higher numbers there, right?
Our statistics kind of consolidated that theory also, because we did see that IPv6 hits from Android users were higher compared to the IPv4 hits. And if you consider that mobile users would be using their cellular data, and a lot of people use ISPs such as Jio or Airtel, which do have IPv6 support. And that kind of consolidates theories. But again, we could also look into whether happy eyeballs does play a role.
You mentioned this campus course management system, IRIS, is it? Did you actually have to do liaison work to help people do a migration to make that dual stack, or was there very little effort required to turn that into a dual stack service? How did that go?
Actually, IRIS is a student-developed information management system. So entirely developed by our alumni and maintained by the current students at NITK. So yeah, it was a student-led effort, even migrating the IRIS applications and servers to IPv6, entirely done by students. So there was a dedicated team working on migrating the applications.
And they got access to your testbed network. They were able to validate that application and make sure it was working. So the future deployments are going to go ahead because they know it works okay in the dual stack environment.
Yeah.
Do you see yourselves carrying on in the network space? Has this experience been sufficiently positive? It kind of makes you think, oh yeah, I could be in networking. It's fun.
Yes, at least for me, I think after having this experience working on IPv6 migration, I'm lucky that I got such a hands-on experience at college as an undergrad student. And I am even more excited now to continue working in this space, continue being part of the migration effort at NITK, and just being involved in any capacity that I can.
And Kavya, you're at CMU next year or this year?
I'll be joining the Masters in Information Networking at CMU this fall. So definitely my undergrad experience in the networking projects definitely made my whole undergrad life positive experience, I'd say, and consolidated my decision to go for higher studies in the same field. And I'm hoping that I'll get to continue working on networking projects. And I'll definitely be helping the NITK community with the projects they take up as well.
So you're both going to become alumni and work on this activity the same way the alumni you worked with did.
Yes.
Carry the story forward.
Yeah.
Oh, it's really great. You got some assistance from APNIC Foundation towards attendance at the IETF meetings?
Yep. So for IETF118, we were able to attend because of the IPv6 deployment grant that we got from APNIC Foundation and ISIF Asia. So we were able to attend through that. And for IETF119, APNIC Foundation selected Kavya and I as one of the Internet Standards Ambassadors to attend in Brisbane. So both the IETFs we were able to attend through the APNIC Foundation. We're really grateful for that.
So is a write-up available of what went on here? Is there anything we can point people at to look at your experiences doing this deployment?
I don't think anything has been published yet. Like, we have documents ready, but I don't think they've been published.
But I could point people at the IETF118 presentation for sure, but the side meeting at 119 was not recorded?
No. The side meeting was not recorded, but we do have the recording for the IETF118.
That's really super. Thank you very much for coming on the program. Thank you, Vanessa. Thank you, Kavya.
Thank you, George. It's been wonderful.
Thank you for this opportunity. And we had a wonderful time.
If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember the Measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time.